Good morning, my dear students. In the last class yesterday, we have discussed about the scientific notation. So, scientific notation and its multiplication, division, these are all the sub parts of uncertainty in measurement. So, uncertainty measurement is nothing but it is a kind of calculating the number system using a scientific notation. So, scientific notation and multiplication divisions. Among these three, the scientific notation will be asked for 1 mark. So write the scientific notation for the number like that it will be asked. So by saying 0.125, write the scientific notation means you should be able to write the first non-zero term. Means here 1 is the non-zero term. Initials are the 0. First you have to write the non-zero term. The non-zero term starts from 1 to here 1. Therefore 1 to 5 I will write. So point I have to shift to the first term is 1. So I am shifting from 1 and 2. So here I am shifting the digits decimal point to the right side. You see here the decimal point is here. By shifting to the right side 1 and 2. After 2 digits I am shifting. So after shifting to the 2 digits, you just check it out whether this number is greater or this number is greater. The first one is 0.0125, it's smaller number, whereas 1.25 is a larger number. Therefore, here we have increased the number. If the number is greater, and we have to reduce the power should be decreased. If number increases, means power should decrease. Therefore, 2 decimals I have changed. The decimal point is shifted to the 2 digits. So it means I have to write the 2 in the minus 2. Can you say 12500? So here point is not mentioned, means a decimal is not there. It means that the decimal will be present at the end, point 0 will be there. So write this 12,500 in the scientific notation means you should be write this as here the decimal point is to the end terminal. So you have to write to the first non-zero term is 125. So you have to write this you have to bring this decimal point to the very first number. First number is in 125. Soon after 1 you have to put the decimal point 1.25 into 10 raised to how much I have to write 12,500 it is, and it is 1.25. So this is very much greater and it is very much smaller number. So I have reduced the number. The number is decreased. If the number is decreased, it means we have to increase the power. Means power should be in the positive. And see here how many decimals it is shifted. This decimal point is shifted from digit 1, 2, 3 and 4. Therefore 10 raised to 4. I hope this is clear. Some of you are carrying the doubts. So that's why I have sending still more some of the problems of this kind. So solve this one and do the practice. And coming to the next one, here the same thing whichever we have studied multiplication and division. Now we are doing the addition and subtraction. And these are little bit confusion and these are having the different kind of the multiplication and division. How means in the last class we have studied at that 1.5 into 10 raised to something. This is divided by just like 2.5 into 10 raised to minus 8 or 9 something like this. Why I am taking 1.5 and 2.5 means for my convenience it will be the easy one to calculate. That's why. Once you look here, 1.5 into 10 raised to 6 plus means we are adding this one. This is the addition and subtraction. In the last class we have observed about the multiplication and division. So while doing the multiplication and division, we are not observing whether the powers are same or different. Powers are same or different. So they may have the different kind of the powers. Look here, while doing the addition and subtraction, must and should we have to observe the powers 10 raised to 6 and 10 raised to 8 is there. I have changed this number 10 raised to 8. Why we have to look at the observe means while doing the addition and subtraction, we should take the common powers of 10 raised to if it is 10 raised to 6 there at the both the terminal, then we can take that as a common. If it is 10 raised to 8, another one is 10 raised to minus 6, means it's not possible to do the addition and subtraction. It is possible, but it is very much difficult. Therefore, look here how means I have written here 10 raised to 6. This is the 10 raised to 8, and the numbers are anything. It may be a 0 or point something or any of the numbers. We have to do the addition here. Before we move to the adding these two, we have to look at whether is there any powers. Compulsorily the power should be the same to do the addition or to do the subtraction. Look here, it is first thing here 10 raised to 6 is there, 10 raised to 8 is there. We have to convert this 10 raised to 6 as a 10 raised to 8, or we have to convert this 10 raised to 8 as a 10 raised to 6. Either we have to take this number equivalent to this one, or 10 raised to 8 should be equivalent to the 10 raised to 6. So first one we will take the easy one. 10 raised to 6, we would like to convert this 10 raised to 6 as a 10 raised to 8. How means, just to look here, 10 raised to 6 I am converting as 10 raised to 8, means I have increased the number, I am increasing the decimals. Two numbers are I am increasing, means I have to decrease this one. Means point is here, means I have to decrease this one. So I will shift this point to the point is initially here. So I will shift this point to here and here. So after increasing two decimals 6, 7 and 8, I am increasing the power of 10 raised to 2 times. 6 is converted as 8, means I increase to d6. It means that I have to decrease the decimals to the left side. 1.5, if 1 behind, if nothing is there, means it will be 0 will be there, means 0.01.5 will be there. So by shifting this decimal to the left side by 2 digits, so it becomes 1 and 2, means here's 1 and 2. 0.015 into 10 raised to 8 plus this is as it is 2.5 into 10 raised to 8 times here 10 raised to 8, here also 10 raised to 8. So we will take the common. 10 raised to 8 is common and remaining is 0.015 plus 2.5. We will add this two. Therefore 2.5 into 10 raised to 8. This will be the answer. How means 0.015. We have to add this number to 2.5. If can you see here, we have to look at the points here. We are not supposed to take to the right side compulsory. Why? Because here while doing the addition, we have to observe that after the point, before the point, the number will be the whole number 1, 2, 3, 4, 13, 15, 16. These are the whole number. After the decimal point, these are the fractional number. Point 1, 2, 3, point 0, like that. So here, point before the point, the number is nothing is there. It means 0, 0.0125. So we have to put the number in comparing the decimal point. Here decimal is here, and the decimal of this below number is here. Means 2.5. Here it is 0.015. So here after 2.5, if nothing is there, means it will be the 0 will be there. So we will do the addition. 5 plus 0 as it is 5, and 1 plus 0 it is 1 as it is, 0 plus 5 as it is, point as it is, decimal point 2 plus 0 is 2. Therefore 2.515. So that's why I have written 2.515, and into common terms are same. 10 raised to 8, the 10 raised to 8 is same as it is. Are you understanding this point? So my step should, what you have to observe here, to do the multiplication and division, no need of observing the powers, whether the power is plus or minus, whether they are near or not, no need of observing. Just we will do the addition or subtraction to the power. But whereas by doing the addition and subtraction, must and should, we have to make sure that these should be same. If they are not same, we have to make them to be a same to make a common. After taking the common, it is possible to add or subtract. So this is the kind of solving addition and subtraction for the using scientific notation. So this is simply the addition, and next one I will take the example for subtraction. The same thing. Can you see 4.67 and it is 0.12. I am taking this is 10 raised to 4 and I am taking this is 10 raised to 6 like that. So can you see that 10 raised to 4 and 10 raised to 6 they are not same. So we will do the subtraction. So to do the subtraction we have to look at the powers. The power should be the same. Here initially one point is 10 raised to 4 and one is 10 raised to 6. So which one we take? If we want to increase this number means 10 raised to 4 to make as the 10 raised to 6 we have to decrease this number. We have to decrease. If you want to convert the 10 raised to 6 as a 10 raised to 4 means we are decreasing this one. It means we have to increase this number. So we will see here. So 4.67 I will keep as it is 10 raised to 4 minus, and I would like to increase this number. So to make 10 raised to 6 as a 10 raised to 8 means I have increased the number by 2 digits. So if I increase it by 2 digits, I have to shift the decimal points to the I have to 6 we have to convert as 4. To decrease the 10 raised to 6 as 10 raised to 4, here we have decreased the power. If the power is decreased means we have to increase this value. So it means that the point is here. To increase this we have to shift this decimal to the right side so that it will increases 0, 1, 2, again 0 is there. You just think like that. If we want to increase this point, the decimal point will shift to the right side 1 and it is 2. So 12.0. I would like to do the 0 of addition. So 12.0 into 10 raised to 4 into 10 raised to 4. Are you getting my point? Just observe it clearly. Here I have converted as 10 raised to 6 as a 10 raised to 4. The power is reduced. If the power is reduced, then we have to increase the number. If power is increased, we have to reduce the number. 10 raised to 6 is converted as 10 raised to 4. The two digits are reduced in the power. It means we have to increase this number. Therefore, the decimal is shifting from left to the right side. 0.12 becomes 12.0 into 10 raised to 4. These two are set. So here we are getting clear point 10 raised to 4 and 10 raised to 4 are same. Therefore, we will take the common of 10 raised to 4 and we will add 4.67. Here it is minus, means we have to do the subtraction. Minus 12.0 or 12, what are said 12.0. So just we will do here. 12 is greater number than 4.67. Therefore, first I will like to write the 12.00 and below I will write 4.67. Look here, I am observing that the decimal point should be the same here. 12 after 12 the decimal point is there. Here it is after 4 the decimal point is there. The decimal point position should be same while doing the subtraction or addition. This is how we have to remember while doing the addition and subtraction. Can you see that the decimal points are below each other? 12 and it is 4 and after the decimal point the number should be same. I hope here we have to subtract 12 from the 4, but the greater number is 12. Therefore, it is not possible to subtract 4. From 4, it is not possible to subtract 12. That's why I am subtracting the 4.67 from 12. So here larger number is 12, which carry minus that. Therefore, answer will be negative. Therefore, 12 using the 12 it is possible to subtract the 4.67. Just I will write it minus, and it is not possible to subtract from 0. Therefore, I will shift to number 10 and again I will take 10. This becomes 9. So 10 minus 7 is 3. 9 minus 6 is again it is 3, and I have taken one number from 2 it is 1 taken is 1. 1 from 1 it will not subtracted by 4. Therefore I will take another one. So 10 plus 1 11. 11 minus 4 is nothing but 5. So point will comes here 5.33 and the greater number carry minus charge. That's why minus 5.33. The answer is minus 5.33 into 10 term is non-zero term, and if it is 0.053 like that, and you have to convert that into the first representation of scientific notation should be by non-zero term. If it is 53 point something is there, just I am showing you 53.3 into 10 raised to 4 like that. Then you have to convert this. The decimal should be to the first non-zero term, means 5.33 into here. Can you see that you have decreased the number? 53 is greater, 5.3 is lesser. If you are decreased, means you have to increase this number. Initially it was 4, then by adding 1 it becomes 5, because you are reduced by 1 digit. Are you getting my point? So this is how we have to do the addition and subtraction. The main thing you have to observe in this one is, while doing the addition and subtraction, the power should be the common. Intentionally, me or the examiner never give the same powers. They will never give the same power, and you have to make them same powers so that you can take the common term to add or subtract. So this is the main important term in the addition and subtraction. I hope you are understanding this one. For your examination point, this is not important. The main important is scientific notation, and whichever I am dealing the next term, these are the important. So let's have some examples now. So these are the homework. Just to try to do the addition for first two and do the subtraction for the second two. And you should keep one very small observation. Sometimes they will give you in the heading, add the following or do the addition for the following and write it. Means they will give the addition, but while giving the problems they will give the subtraction. Means you are not supposed to look at the sentence what they have given. If they say you to add the following things, means it's not possible to add. The addition and subtraction of the terms depends based on its given sign. If the sign is negative, then must you have to subtract it one. If it is plus, then you have to do the additions. Are you getting this one? Just look at this one and try to solve this one. Okay. The next one, precision and accuracy. And even your physics, you have studied the precision means precise and accuracy. So here, whichever you have dealt in the physics, the same concept, the same meaning will be there in the chemistry also. So precision and accuracy is nothing but, the precision is nothing but, just to take the example, if I give any two students to calculate the weight of this watch, and I am going to give the some manual weightage, how to calculate the weight. So think that the exact weight of this watch is around 200 gram. Just I am telling you one example. 200 gram. If it is 200 gram, think that A and B are the two persons. A and B are the two persons, and C is another one. They are going to do the addition. They are going to do the weightage of this watch. So first time the person A will do the weightage, and he will say that the weight of the watch is around 195 gram. The first time he will weigh and say that it is 195 gram, and second time when he weighed and he said that it is 197 gram. Can you see? Whenever somebody is said to calculate the weight means, or any while measuring, we are not measuring only once, we are measuring 2 or 3 times, and we are taking the mean of that one. Means while calculating the same thing, while observing any of the thing, we are taking 2 or 3. If we are taken 3, we are adding the 3 and divided by 3. So it means that we are taking the mean of the measured value. Similarly here also the person A, he measured this watch by 2 times. Initially he is getting the value 195 gram, and second time he is getting as 197 gram. So can you see here? The person A getting the 195 and 197. These two values are near to each other. They are very closer to each other. If the any two observed value or measured value, you can take any of the. It's not only about the weightage. You can take any length, or you can take any temperature or measurement, any of the units measuring. If the measured values are near to each other, if the same person measuring the values they are near to each other, then we are calling that as a precision. The person A which he measured the value, these two values are precision. Precision is nothing but what? It refers to the number closer to each other. Can you see 195 and 197? These are the closer to each other. Whereas the person B, he is calculating, he is measuring the weightage of the same watch again, and he is saying that it is 190 gram, and one sometime, and another time he is saying that it is 202 gram. 202 gram. Can you see it? Initially it is 190 gram. Next time he is saying that 202 gram. First time the weight is he observed is 190, and another time is 202. So it means that these two values are not same. Means they are not closer to each other. They are very much far away. Therefore, the we observed values, these are not precision. These are not precise. Why? Because they are not closer to each other. Whereas the person A, he calculates these are closer to each other, whereas these are not closer to each other. So same thing, the person C is calculated, the weight of the watch is 198 gram initially, and second time he is saying that 202 gram. Can you see here? Otherwise you take 199 and it is 201. 199 and 201, these are near to each other, isn't it? They are only having the difference of 2 units difference. 199 and 201, these two values are closer to each other, therefore these values are precision. So precision is nothing but it is going to refer the closer value or closeness of the value of any of the referring number. If the referred number is whichever they are measuring, they should be have the closer to each other. Such kind of numbers are called as precision. Whereas second one is accuracy. Accuracy is nothing but the measured value should have the same value of the given value. So I said that the weight of my watch is around 200 gram. The 200 gram accurately if it is getting means the same weightage they are measuring means that value is called as accuracy. How means? Can you see here? You just take the mean of this one, 195 and 197. So the mean will comes 196 means it is not the accurate value. So 190 and 202, the mean of this one will come around the 196. These are not the given value. Whereas 199 and 201, you just I'm adding the two values. Adding the two value, and I am going to get 400, and the two value divided by 2, I am going to get 200 gram. So here 200 gram is the given value. So here the person A measured two values are closer to each other, means they are precision, whereas the person B calculated values are they are not closer to each other, means they are not precision. Whereas C is calculated, they are precision because they are closer to each other. And coming to the accuracy, they are not accurate. By taking the mean, we are not getting the given value. Therefore, these are not the accurate. These are also not accuracy. And whereas the person C calculated, these are precision and also they are accuracy. By taking the mean, we are going to get the same 200 gram. So it means that the person A observed value, these two are only precise but not accuracy, whereas B person measured, these are neither precise and not accuracy. Is it clear? Because they are not getting the 200 and they are not closer to each other. Whereas person C calculated or measured value, they are precision and also accuracy because these two are the closer to each other, and the mean of these two number will be the same as the given 200 gram. Therefore, it is accuracy. Are you getting my point? So it will be asked for more marks. What is accuracy? What is precision? Like that, it will be asked. They are not asking any theoretical parts, means calculation and other criteria. So nothing will be there. Okay. So don't worry. You just try to understand. Accuracy is a reference of closer number. Accuracy is nothing but the exact number of the given data. This is the difference between the precision and accuracy. So you can able to write the definition based on this one. So looking at the initially from yesterday, so we have discussed the scientific notation and it is important for 1 mark. They will give you any of the number and tell you to be write scientific notation form. So it is important for 1 mark. And coming to the multiplication, division, addition, subtraction, these are not asked in the examination point, but somewhere it may ask you, but they will give you some of the problems to solve that one. So based on the taking mean, you can able to solve the addition and subtraction, and to any of the powers you can do the addition and multiplication and division. So keeping in that one, the main very important concept in this uncertainty measurement is the significant figures. What is significant figure? The significant figure is nothing but it is a representation of number of terms which are having the values. Values are nothing but these are the some criteria, some figures, some significant figures. By that we should be able to determine or say what is the significant figure of some value. So here actually there are 5 terms are there, 5 conditions are there, 5 rules are there to say the significant figures. It is one of the most important in your this exam and for this chapter also, and it is very interesting and easy one concept. It will be asked in the annual exams also for same thing for 1 mark because it is very easy one. So coming to the first rules, to say the significant figure, which number and how we have to say the significant figure. So keeping the first one, here they are giving you initially point 0.25. 0.25. Look here, the first one saying you the rules. The first number is the significant figure. If they will give any of the number, you have to say that what is the significance of that number. So 0.25 or something they may give. If the significant figures are not considered for the zeros of initial number, zeros means non-zero numbers are not considered as, all non-zero digits are not considered in the significant figures. Means initially it is having 0.25. The significant figure of this number is only 2. The non-zero term is 2. If it is, think that it is example 1, and the second one 269 is there. It is only having numbers, therefore total numbers are 3. Therefore significant figure is 3. The third one, we just take the example 0045. If they have given like this 0045496. So here you have to observe that. I think you are not observing. Not visible. 0004946. This is the example. Look here. So initially we are having the 30, means 0 terms are there. The non-zero will begin from here 49465. So initially non-zero terms are not considered as a significant figure. Only the non-zero terms are considered. Means here the zeros are not considered. Non-zero terms are nothing but the apart from the 0. How many zeros apart from 0? 1, 2, 3, 4, 5. The significant figure of this number is 5. Are you getting my point? Very simple concept. Significant figure in that we are not supposed to consider the initial zeros, the zeros which are coming in the first initially. So we are not considering. This is the first term. And second one is here in the second concept we are considering that the significant figures are considered for the zeros which are present in between, the zeros which are present in between the non-zero terms, which are present in between the non-zero terms. 2005. So can you see the zero is present between the non-zero terms 2005. Here total number of digits are 1, 2, 3, 4. We can't neglect the zero because including the zero the value will be greater. Therefore the total, the significant figure of this is 4. Are you getting my point? Similarly 2.0085. Total numbers are 1, 2, 3, 4, 5. The significant figure of this is 5. Are you getting my point? So this is the second term, and the next one is the zeros at the right side are not considered in the significant figure. The zeros in the right side are not considered in the right side unless and until they are after the decimal point. Means before the decimal point zeros are not considered. Before the decimal points are not considered. Can you see here? Here 0.02500. Here after the decimal point, how many numbers are there? After the decimal point, this is the decimal point. Before 0 is there, but we are not considered. After the decimal point, if the 0 comes, means we have to consider that one. Here the number 1, 2, 3, 4, 5. We are not supposed to neglect this after the 2, 5. Obviously, it is not having value, but while saying the significant figure, we have to consider this value. Means what? Just to look at this one. 2.50. The significant figure of this one is 1, 2, 3. Here 0 is there, but here if the 0 is there after the decimal point, that is why we are considering this one. The significant figure of this number is 1, 2, 3. 1, 2, 3. If you just look at the value is 250. If it is 250, this time we are not considering the significant figure. The total significant figure if this is only the 1, 2. 2 is the significant figure. The numbers 1, 2. But we are eliminating the zeros at the right side if it is not having the decimal point. If the decimal point is present, then only we are considering that as a zero term. Are you getting my point? One more example I will. 100. The significant figure of the 100 is, can you see how much it is? If it is 100, the significant figure is only 1 because the decimal point is not there. It means it will be there, but it is present at the end, 0. But if it is not mentioned here, it is not mentioned, means it is, we are not considered as the decimal point. If it is, we write the decimal point, means we have to consider this point. That's why we are not writing 100 means 100. If it is 100, the decimal point means significant figure of 100 is only 1. 100 is only 1. If the same thing, if it is 100, if it is containing point, at that time we have to consider that. So significant figure of this is 3, means 100. The significant figure of this point is 0. The same thing 100. Point 0 is there. No doubt the 3 values are same, 100, 100, 100 only. But here the decimal point is not there. It means after the non-zero terms we are not considering. After the non-zero terms are considered, means zeros are not considered at the right side. But 0 at the right side are considered if it is present after the decimal point. After the decimal point, if the decimal point is there, then we are considering that one. Here it is 3. After the decimal point, 10 is there. Means including that one, 1, 2, 3, 4. The significant figure is 4. If the decimal point is not there, then we have to neglect that zeros present at the right side. Same thing here also. Initially, the zeros we are not considering. If that 0 is present after the decimal point, we are not supposed to neglect that one. We are not supposed to neglect the same values. Are you getting my point? The same thing. Here I would like to give one more example. 0.025. Here the decimal points after this decimal 0 is there. Means you have to consider this one. The significant value of this one is 0, 1, 2. It means 1, 2, 3, 0, 2, 5. We are eliminating this one and we are considering the 0 after the decimal point. This is the decimal. After the decimal point 1, 2, 3. 3 numbers are there. Therefore significant figure is 3. Are you getting my points? So based on this, you should be capable to write the significant figure. Actually here I made 2 rules together, so no need of confusion. And next, last one is not the rules, it is for our convenience. The 2 is having a significant figure is 1 because it is only one digit. 20 is having a significant figure 1 because after the 2, 0 is there, but in here there is no, I have not mentioned the decimal. If 20 point means that significant figure is 2. If 20.00 means the significant figure is 4. 20.00000. How many zeros are there? After total division 1, 2, 3, 4, 5, 6, 7. That is significant figure is 8. Are you getting the point? So after the full point, the total number of zeros are considered. Okay. So look here, I have given some of the examples 1, 2, 3 up to 8. Try to write the significant figures. I hope this is not very much difficulty, but it will be easy if you practice that one. And if you are feeling any difficulty, just ask me. Otherwise, if you feel still more when I begin a live video, at that time I will solve you some more difficulties. Okay. So we will meet in the next video. Until if you are having any doubts, ask me. Okay. Have a nice day. Bye.